Okay, so this problem is a little different than one we just did. It's the same instructions, solve the system of linear equations by elimination. So we're going to eliminate something, but unlike in the previous example, go back and show real quick. There was a positive 2y and a negative 2y. So when I just add them straight down, they eliminated each other. On this one, if I add these straight down, they don't get rid of it. The x's are still there. If I go straight down here, the y's are still there. So nothing's being eliminated. So somehow or another, we have to make one of these variables to get eliminated. Well, that goes back to the very first step. Now, we don't always use this first step, but in this case we do. We need to multiply, if necessary, one or both equations by a constant, by a number. So at least one pair of like terms has the same or opposite coefficient. Another way to say that is we need to multiply one of these equations so that it's opposite of the coefficient of another equation, so that when we add them together, it's eliminated. Okay, let's go ahead and do this. So I'm going to rewrite this here just so it's I have a little more wiggle room here. And I'll rewrite the other one next to it. Running out of room there. Okay, and now looking at this one right here, if I look at these equations, if I multiply this bottom equation by a number, or this top one by a number, it can help it be the opposite. So, if I were to multiply this bottom equation, say I want to get rid of the x's, what would I have to multiply this bottom one by? Well, this is a 10x and this is a 5x. So, in order for them to be opposite, if this is a negative 10, this would have to be a positive 10. So I need to multiply it by a negative 2, the whole thing. And that would get rid of the x's. I, however, am going to take a different strategy, and I'm going to get rid of the y's. Okay, and so let's go ahead and do that. In order to get rid of the y's, I'm going to multiply this whole top equation, the whole thing, by a 2. Why would 2 be a good option to multiply it by? Well, because this is a positive 3y and this is a negative 6y. So in order for these to be eliminated, they would have to be opposites. So if this is a negative 6y, this would have to be a positive 6y. Well, how do I turn a 3 into 6y? I multiply it by 2, because 2 times 3 is 6. However, I can't just do one term. You have to do the whole term. So we multiply this whole term, the whole equation, each term, by 2. We're often used to changing one term. We're not usually used to changing everything. But remember, if you do something to one side of an equal sign, you must do the exact same thing to the other side, or so it wouldn't be equal. So we're multiplying the whole thing, that's both sides, by the same number. Okay, so 2 times a negative 10 is negative 20. 2 times 3 is 6y. And then 2 times 1 is 2. Alright, the other one we can leave exactly as it is. I like to write them underneath each other. Oops, that's a negative 6y, isn't it? Sorry. Equals 23. Now we can just add them straight down. A negative 20 and a negative 5. A positive 6 and a negative 6. Oh, those are the opposites we were trying to get. Now that they're opposites, a positive 6 and a negative 6, they eliminate each other. Oh, the elimination method. Okay. And then 2 plus 23 is 25. Then we just solve for x, like we always would solve for x. X equals a negative 1. Okay, we just need to go back and find y. We have a couple choices here to find y. We could substitute it into the first equation. We can substitute it into the second equation, or our newly third equation that we just made would also work. I could choose any of these. I will go ahead and choose, well, why not? Let me choose this one here, right? I'll choose the top one. So negative 10x plus 3y y equals 1. Negative 10, but instead of an x, we now know that x is a negative 1, so I'll substitute it in for negative 1, plus 3y, I'll just bring everything else down, equals 1. Negative times a negative, so positive. Okay, and then we just solve for y here, so bring down the 3y, equals negative 9, divide, screw down a little bit, y equals negative 3, so we have our x, and we have our y, so we have our ordered pair, we have a solution to the system, and then you can always check by substituting it back in. I'm going to do it this time. I'll just choose the same equation that we just did. Negative 10 times negative 1 for the x, plus 3, and then the y, instead of a y, we'll put in a negative 3, equals 1. 10 plus a negative 9 equals 1. 1 equals 1. Yay. Okay, so we did it right. The answer is a negative 1, 3. Great. So sometimes we have to multiply an equation in order to get the terms to be opposite. Okay, it's your turn to do number 1 and number 2. Number 1, notice that they're already opposites. Number 2, you might have to do something to turn it into an opposite. Let me know if you need any help.